Welcome to today's webinar, Build Smarter Apps with Einstein Platform Services. Thanks for joining. We are very excited to share this information with you today. I'm your host, Chris Chant from Developer Marketing here at Salesforce, and today we are joined by a great group of Einstein product experts. We have Katie Hurley, Senior Manager of Product Marketing, Michael Machado, Director of Product Management, and Shane McLaughlin, a Principal Demo Engineer. They're going deep on Einstein Platform Services, where we'll learn how to train, deploy, and integrate deep learning models into our applications, as well as many about use cases that you can start exploring today. Before I begin, just a quick note that when considering future developments, whether by us or with any other solution provider, you should always base your purchasing decisions on products and features that are currently available. The key takeaway for this forward-looking statement slide is that we are a public traded company. Please make your buying decisions only on products commercially available from Salesforce. Also, we are on all the social channels. Please keep the conversation going on social media. We're on Twitter, Facebook, LinkedIn, and YouTube. You can use the hashtag EinsteinAI for your posts. And with that, we are ready to get started with today's session, Build Smarter Apps with Einstein Platform Services. Up first, we have Katie.
So hi, everyone. It's great to be here today. My name is Katie Hurley, and I'm on the Einstein Product Marketing team. We have a jam-packed agenda for you today. We'll be covering a little bit about deep learning and why it's important in today's age of technology. We'll be talking about our amazing platform services, and we'll do a deep dive on one of our newest APIs, Einstein Language. We'll be showing a demo so that you guys can get started after this webinar on your own build-outs. So the biggest thing to note when we think about where we are today is the amount of data that has been generated. I'm sure we've all come across statistics that more data has been generated in the last 5 years than ever. But what's interesting about this is it's not just any type of data, it's a special type called unstructured data. And it has to do with the way that we communicate and how it's evolved. So when you think about it, we have social platforms, we have applications, we have connected devices like Alexa, and these different devices and apps generate data like text data and imagery, if you think about Facebook and Twitter, and also voice. And in order to make AI work, you need data, you also need compute power, and you need the right algorithms. And so when you think about taking advantage of unstructured data, deep learning is one of the best AI techniques. Deep learning is very adept at pattern recognition, and we like to think of it as simple input, simple output. So if you feed a deep learning algorithm images, for example, it will learn the key attributes across those images, and then it will be able to predict what a new incoming image is based on the classifiers that it's been trained on. Similarly, with text data, you can feed text data and get interesting outputs around sentiment and intent. So new applications so that you can start to essentially build AI into your apps using deep learning and taking advantage of unstructured data. And so at Salesforce, a big principle for us in the creation of Einstein is how do we take something seemingly complex like deep learning and bring it to the masses? And how do we start to build parity amongst our consumer experiences with apps so that we're bringing that same kind of intelligence into our enterprise applications? And so with that, I'm going to turn it over to Michael Machado. He's our head of product for Einstein Platform Services. He's going to tell you a little bit about how our platform is differentiated and how you can get started with some APIs today to build some of the apps that we're referring to.
Thanks, Katie. So when we think about democratizing deep learning for our developer community, it isn't about just making it easier to use. We try to provide a complete end-to-end solution. So not only are we delivering APIs that are well documented and take you through the entire step of training a model to deploying a model, we also provide this through a hosted infrastructure that provides all the underlying GPUs and compute power necessary to run these models. We integrate this with Salesforce seamlessly and continue to provide new integration components to make that process of building AI-powered apps hosted on top of Salesforce or integrated with a legacy or net new application, very seamless process. And then we give you the best in breed research data scientists that we have at Salesforce to update these models, make them stronger over time, and really ensure that you're going to have the most powerful deep learning algorithms supporting your models as you start to build these applications and update them. So getting into the granular, what we have available today, we have two families of products as part of the Einstein.ai platform services. We have Einstein Language and Einstein Vision. We talked a lot about Einstein Vision in the past as part of our image classification suite, as well as object detection, which is our latest advancement in Einstein Vision. And today we're going to be kind of doing a deep dive into the Einstein Language family. Today that's Einstein Intent and Einstein Sentiment. Looking back at image classification, just as a quick refresher, we delivered a GA feature last year that allows you to build and train deep learning algorithms to recognize objects and images. This has been integrated with Salesforce. We've seen some great applications being built on top of this platform. And then we've evolved that image classification suite of services to add an object detection. Well, this gives you a little bit more of a granular output where you're able to identify multiple objects within a photo, understand their size, height, and width, as well as how many times they appear in the photo. We're going to be doing more information on object detection in the future as that product becomes openly available as part of our beta. Today we're going to be going through our Einstein Language suite, so we do want to take a second kind of outline what is Einstein Intent, what is Einstein Sentiment. So Einstein Sentiment is a pre-trained model that gives you the ability to send us unstructured data in the form of text, and we will classify it as either positive, negative, or neutral. And you can see lots of applications being able to apply this within the sales, service, and marketing industries. Einstein Intent takes that concept and gives you a little bit more flexibility and customizability. So instead of saying exactly what the outputs will be, in the case of sentiment being positive, negative, or neutral, we actually allow you to define those on your own. So you provide us supporting data for any classification you want us to output, and we will allow you to train a model through simple API calls through the entire end-to-end process, and then give you easy ways to integrate this. So this sounds complicated right now, but once we show you the demo, you'll be able to see how these all kind of allow you to build AI-powered apps and start to give you some ideas about how our customers have already started to adopt these solutions. We've seen sales applications leveraging smart notes apps, making it easier for sales reps to capture information from customers and then be able to kind of have a metadata outlook on what those notes were and how they can leverage those in the future. Service are using this for smart case routing, being able to get the right case in real time to the customer or to the agent that's best able to handle the customer's complaint. And then marketing, being able to understand the feedback coming in from customers and being able to classify that as positive, negative, or neutral, or maybe what department's best able to handle that feedback information. And as we start to think about how to build these models, it's great to have a visual of kind of the end-to-end solution, which is really how do you go about solving your problem and giving you the supporting data to support that. So you can define your classes, and this is really when you start to think about the problem you're trying to address and what outputs you want out of the model. You start to gather data that helps you build that model and strengthen your model, and there's lots of best practices we can talk about as we go through the end-to-end demo. Feel free to save your questions for the end, and we can talk about what are the best practices to think about when training your algorithms. And then finally, we give you lots of parameters to fine-tune your training models, but also think about building this in an easy-to-adopt way where you can just click train and have a model that's ready to go for future predictions. Now that we've kind of gone through the end-to-end, I think it's best to kind of see this in action. So I'm going to pass the mic to Shane and allow him to take you through both a demo within Salesforce, but also all the supporting code that went into building these models.
All right, hey everybody, I'm Shane. I'm going to start off here in Salesforce. I've got a custom object, and when I click New, our scenario here is that we're a manufacturer, and we have a lot of dealerships, and we also have a partner community that they can come on and look at inventory and request more products and interact with us. But one of the things they can do in this community is to create feedback. So our custom feedback object, people can type in things like this and complain about their dealer app. And then when we save that, you'll see the record save, and then we're going to get some predictions back from Einstein asynchronously, and you'll see the page update in just a second. Allegedly. All right, I'll update it manually and get these. So we have a 82% chance that this is some negative feedback, and it's pretty strong negative feedback. And so how did these things happen? We have a sentiment field here that I created, and there's also a probability field for storing that sentiment prediction. And so to make this really easy for our admins, this has been set up as a process builder action. So for our feedback classification, I'll open this up. So if you haven't worked with Process Builder before, you pick the object, and then you've got some criteria here. And so this criteria basically says we do have comments in our feedback, but we don't have any sentiment yet. And when that happens, we want to make a call out to the Einstein APIs, send it our text, and get back our sentiment analysis. And so I've got some 4 fields here. So as the admin is building this, you can say, here's where my text is stored. Here's where I want you to put the result. Here's the record ID that we're working on. And then optionally, you can also store that probability so that people can see what level of certainty the model came back with. And then if you want to dig one level below this, the way these are set up as Apex actions. And I'm going to open up VS Code and give you a look at it. If you haven't built Apex model actions for Process Builder before, they use this invocable method annotation. And what I'm doing here is going through this list of language requests. And as you're creating them, you give this inner class your invocable variable annotation. And that determines what shows up in Process Builder there for the admin. So this is the record ID, the field to analyze, the label field. Those correspond to these things right here, and these are the labels. So this is basically how we get from the Process Builder click stuff to our Apex code. And then once we're in Apex, I've got some other classes here. This is the actual prediction class. So I'm passing in the model type, the model ID, and I've got some defaults here. So if you don't give us a model ID and you don't tell us what you're doing, we're just going to assume it's sentiment and use that community model that Michael was telling you about. And then you've got some options to be more specific than that. And then at that point, we're going to handle everything of taking those parameters and passing them to the APIs. And there's one more class here that is dealing with the HTTP requests. And if you've ever done callouts in Apex, it's not that exciting. But we're doing the callouts for you and also handling the access token for dealing with the Einstein APIs. So that's a quick look at how this is structured. And you could write a trigger as these feedbacks come in. But I think this little model with Process Builder, I think is a lot more sustainable. So if you're a developer and you're working with an admin and they come to you with one use case and they swear to you that they will never ask you for another use case, you might not want to go through the work here. But if you would like to say, here is your Einstein sentiment, use it wherever you would like to use it, and don't call me again, that's a good way to handle that. So that was our standard model. The other thing that we saw, if we go back to our feedback, is that we're classifying the topic of this sentiment. And so I've got a few topics here. We're dealing with apps, we're dealing with marketing. And this topic is based on a custom model that we have. And so if we look back at our Process Builder, I've got another action here for, you have a comment, but you don't have topic. And there's an action here for get intent. So we're reusing that same Apex class that we saw earlier, except this time we're going to be more specific. So I've asked for the intent model, and I've got a specific model ID that I'm using. And so this is a model that exists over on the Einstein side. This is a custom model that has been created off of my data, and I get this model ID. So instead of using a community model, this is specific for what my dealers tell me in my dealer community and how we classify it. And so I'm going to show you what the Einstein docs look like for creating these data sets, and then we'll walk through some of the helpers for that. So typically, if you're creating a data set, we're going to give it a file, and it's a CSV file. The first column is the data, and the second column is the classification. And you can create your data sets, and then once you've got your data set created, you're telling it what type of model, you're giving it the URL of the file, and we're passing all that stuff over. And then once we're done with that, we also have some requests that we can train the model. And there's some training parameters and various things that you can do here. But the idea is once we've got that, it'll go into this status of queued, and then we'll see that job running, and then eventually it'll be complete. And this is that model ID that we looked at in Process Builder. And so this is the thing that comes back that you'll want to store and use in your requests. So we could do this from Postman, we could do this from curl, and a lot of the examples are working that way. But one of the things I wanted to do was to handle the scenario of how do I make this easy for people to prototype in Salesforce? And so I have a custom object for language models, and I'm going to create a new one just to walk you through this. So all I have to do is tell it that I'm trying to create a custom intent model, and I'll save it. And then I've built a few Lightning components, and if you're getting impatient, I'll let you know where this code is towards the end. There's two things you can do. One is you could say, I have all my data in Salesforce. I've been classifying it manually for a while. So what I'd like to do is find this feedback object. And then I'm going to pick where my unstructured data lives. So I've got a comment field. So the dealers are providing comments. And then my existing data, I've been classifying it in this topic. So I've got some data with topics on it. And then once I pick those two things, I've got two options. I'm going to click the Get File, and that's going to export that file and save it here in the chatter feed. And that way I can look at it. Maybe I want to clean it up or something like that. And then I can also just click this button that says Build Dataset. So when I do that, we're going to make the call out to Einstein. There's some Apex classes behind this. And you'll see that we now have a dataset ID that got created for us. And then as soon as we get back the data, you can see that I've got 30 total examples here of my 3 different topics from data that was in Salesforce. So if you have a whole bunch of text data already that you've classified manually, this is a really good way to get a data set built quick and dirty so you can prototype with it. Once we have a data set with some examples, Michael, it's a minimum of 7 now, right, for each?
I believe it's either 5 or 7.
Yeah, I think the minimum is 7. We used to get away with really small data sets and they didn't work very well, so we put some minimums in.
Yeah, and it's really best to think about quantity and quality data, taking your time to develop a high quality data set versus trying to build a quick model. But for the purpose of a demo, it does let you at least get to visualize your model quickly.
So once you can see your labels on your data set, I've also got a button here for train model. So it's going to call that API that we just looked at earlier. And you can set some of the training parameters. And you can see here's that model ID that just got created for us, and it's saved here on the record. And then if we look, we can see we went from queued status to running, and this thing's going to gradually move up through the percentiles until it's done training. And at that point, we can make calls against this model ID instead of the one that we had set up. Maybe this is better. All right, so at this point, Michael, what do you think of my data here? Is this the best data set that you've ever seen?
So we have one quick question. Well, looking at the data, I would say that, first off, it's good that you defined your classes well, and you've got a decently well-balanced data set. And that by well-balanced, each class, marketing, products, and apps, has a relatively equal amount of examples. Now, what I'd love to see is bump up those examples by probably at least 10x. Really to get closer to 100 per class, or at least let you to start develop a great baseline. And then from there, you can start thinking about, okay, how are these classes performing? You start to get a little bit more granularity on your model metrics. And the reason being is because we take around 20% of your data out of training and allow that to test our models, it's better to have more data available to test the model, knowing that that's going to give you sort of a rough expectation about how your model will perform in production.
Makes sense. I've also got some stats here so that as the things come back, we can start looking at some of the quality metrics and the confusion matrix so we can see which types of things are getting confused with another type of example. And we would get that all once we get 100% of our model done. All right, we're not going to wait for that. No. The other thing that we can do, and this is probably a lot more common, is that you may have all of your data from another system and you've exported it, and so you're preparing a CSV file. You may also have all your data in Salesforce and you feel like exporting it because you need to clean it up and maybe make sure that you've got about the same number in each example type. That's also a thing, right? We want to keep them mostly equal.
Yeah, nice balanced data. So the model's going to learn patterns. So if your pattern shows that it's very rare to see a single example or one example is going to show up more, you're actually going to see that pattern reflected in your model.
So we want our example distribution to reflect what the real life population distribution is.
Exactly.
Okay. All right, so I'm going to pull down this CSV file and show you one example of what we can do with that. So sometimes, if we're trying to do the exact same thing without going straight from Salesforce data, we can create one of these. And then all you have to do is attach that file to the chatter feed for the model. Once that's done, just like we did with this component here, create data set from attached file, will read all the files in your chatter feed, and then build a data set directly from that. So if you have a CSV file, then you don't have to go through the process of dealing with uploading that and using the auth tokens and stuff. So those are a couple examples of how we deal with the custom data sets and custom model training. And then you can take that and use it there. The other thing that we wanted to look at that we get a lot of questions about is what happens when we get the model wrong, okay? And as Michael was saying, my model that we were looking at doesn't have nearly enough examples of all the different types. And it's probably going to be pretty common that I get back wrong answers. Yeah. So when someone saves one of these and we classify it and we have to reclassify it, it would be really cool if we could add all those reclassifications to the model itself. So I'm going to go back over to the one that had finished running, which is feedback classification. All right, so you can see I've got 30 total examples, 9, 12, and 9. And then I'm going to open up that feedback that we just looked at a second ago. All right, so here's our feedback. And it is possible that if I reclassified this, I would want to say, oh, you got the topic wrong. This is actually related to our products and not related to our apps. And so if I were to save this, I would want to add this to my examples as a better example. And so I've got that same thing created in Process Builder that we were looking at earlier. This is a new process called feedback learning. All right, so this is our reclassification process. And so just like we did before, we're using the feedback object. And I created some criteria that define what reclassification looks like. And so in this case, we have a comment, but that topic field that we're storing the prediction from the previous example, anytime you change that, we're assuming that someone manually went in and changed that. And anytime that happens, we want to create that as a new example. So just like we did before, there's an Apex class behind this. And so we're going to provide what the text is. This is the correct label. This is what a human being changed that answer to. And then we're going to put that on the same model that we had earlier. So it looks pretty similar to the other one. Those are those 3 fields that showed up in Process Builder. And then there's an Einstein method on the API that we'll look at for giving feedback examples. And so we pass in the model ID, what the answer should have been, as well as the original text. And that's how we're creating these examples. And so what we want to show here is that when I save this and go back and look at our feedback classification, we no longer have 30, we should have 31. So there's 31 examples, and you can see that we added one to the products category. And then at some point, we can go and retrain the model and incorporate all that feedback so that every time we get something wrong and a human has to touch it, then we get better data as we go. And then the only thing you have to worry about here is making sure that our distributions don't get skewed, right? Do the feedbacks count the same way as regular examples?
Yeah, in the end, you're really running a complete retraining of your entire model. So 1 or 2 examples probably not worth retraining your entire model, but as you start to get maybe 10% feedback as compared to your original data set, it's a great time to retrain it, evaluate it, and then you always can kind of look at the model and see if it's getting stronger or getting worse. We do allow you to even overwrite your current model or create a net new model from that feedback.
Yeah. The great thing about working with data that's in Salesforce as opposed to data that's in your CSVs is that if you rerun the data set, it actually reflects all the data. So that should be your total population. It should match your examples. If you're working with data from another system, then that's a little bit harder to do because you have to make sure those distributions are still working in about the same way. All right, let's go check on that one that we were looking at earlier. So this is the webinar demo. You can see this one finished, and as we retrain it, you'll see updated times that don't necessarily match the created times, and that's a good way to check on it. And then we can also, like we looked at earlier, we can look at its stats. And you want to walk me through exactly how this confusion matrix works and what we get back from the model?
Yeah, so as we pull out, so you have your training data and you have your test data. Now, training data is actually what your model has seen before, but test data is held back from model training. And we use that to create a, essentially after every time we do an epoch or a revolution through the model for training, we test to see if the accuracy is increasing, and then we continue to train the model. Now, at the end of the training process, we provide you a final output of that test data and how your test data scores against the model. And we give you a bunch of interesting metrics to then review. Now, you'll see F1 scores, which is a combination of your precision and recall, as well as a confusion matrix and a precision score across your entire model. So precision score is the test accuracy. As we said, not a great training data set. So our test accuracy is coming in around 37%, and our training accuracy is based on the data the model has seen. It isn't the best reflection of what your model will look like in production, but it typically does give you some signal, as well as training loss, which you'd like to have below that number, below the numeric number 1. So we've got obviously work to do to make this model stronger, but we knew that going into it. And the final piece here is this confusion matrix, which can be confusing to look at if it's the first time you've seen a confusion matrix. But what you have is the predicted score on the top and the ground truth on the left-hand column. So each one of those classes actually make up a graph where you're trying to optimize for the diagonal. So the top left 2 means for the 3 sets we had within marketing, we got 2 correct and 1 wrong. For the products, you can also see that, and then we didn't get any examples from apps because we didn't have a large enough data set to actually randomly select an apps example. But what our goal would be here is to have the top left corner, the middle, and then the far right encompass all of our examples, and that means we would have 100% test accuracy.
So the goal here is that I would need to add more examples to each of these things and then redo a train, and then I would come back and look at these and see if I got better data, better scores. Exactly.
You'd see if that diagonal from left to right was actually getting more and more sample data included in that diagonal. And you can also see where you're having the model being confused by. So if there's a class that's overlapping, you can decide, do I have bad data supporting that class, or potentially these classes very similar, would I want to combine them? As you start to get to maybe hundreds of classes, the idea of combining classes, if it increases your accuracy and you can still gain value from the application, is something to consider.
When you say classes, you mean my labels here. So like my text can't tell the difference between the products and the apps, and it's confusing them.
Yeah, essentially our model doesn't care if you label those A, B, C or marketing products apps. We use that training data to develop our own kind of essentially signal for that label.
All right. And then if you're curious as to how these things work, this is a Lightning component, and right behind it is an Apex class. And the Apex class is calling out some of the methods that are getting these scores. So for example, this method that we're looking at right here is the get training metrics. And so you'll see some of the stuff that was showing up in that model on the Lightning component is the same stuff that's coming here from the same model. This is what it would look like if you just made the raw REST calls. And so as you're developing, you can choose whichever way is more useful for you. If you're rapidly iterating and stuff, you may just be doing this from the command line or the REST API, and you'll get some of those same scores. And then maybe you need to go back and do what we did, which was add some examples or create some more feedback. And then you would call retrain the data set, and then we would call this again and see if we got better numbers, right? All right, so hopefully that gives you an idea of some of the components that are here. We have, I think, a lot of the questions relate to, do we have access to this code? And the answer to that, of course, is yes, because why would we keep all the good stuff for ourselves? So this is my GitHub. This is me on GitHub and Twitter. And this repo is unfortunately named Einstein Vision because that's what came out first, and I just never renamed it. But you'll see a whole bunch of things in here for both the Vision API from V1, but also all the new language stuff. And there's some setup instructions. If you haven't signed up for an Einstein.ai account, we're going to encourage you to do that. But there's also some security things that you'll go through that process with getting your tokens set up and your security key uploaded. And then at some point there will be some custom settings that you'll set where you'll want to put in your token expiration time and stuff like that, the username that you signed up with. And then everything specific to language is down here in the settings. And so, for example, some of the stuff that we looked at in Process Builder, which was how do I make sure that I'm not calling the thing twice and that I actually have data in it. So these are some of the formulas that are there for like the example of case classification, which was the first one that I built. So there's code here that's useful for you. And if you haven't used this button before, this was created by Andy Fawcett at Financial Force, but there's a deploy button. And once you authenticate to your org, it will deploy this through the metadata API. And then you have all the code available. And then you just have to go through the setup steps. So we're trying to make it as easy as possible for you to do some of this language stuff. And I guess my last call to action is that I do have a Dreamforce session on this for admins in the admin track. So rather than walking through all the code and the APIs and showing you, it's more aimed at your admin who might be coming to you to request all this custom model building and API calls to the Einstein APIs. And you could hand them this package or maybe install it for them. And they can come to this session and see how to do all the process builder side of that and the model creation from those Lightning components so that they maybe don't need as much dev time from you in your upcoming years and your project backlog can stay a little smaller. All right, so at that point, we're going to flip it back to Katie.
All right, that's it, folks. As Shane mentioned, you can try all the stuff out at Einstein.ai. Be sure to check out. Shane, are your code samples at Einstein AI, or are they going to have to go to your GitHub repo to get those code samples?
They're on my GitHub.
Great.
I don't know. If I ask Michael really nicely, maybe he'll update his stuff.
What we'll do, folks, is in our follow-up email to this webinar, we'll make sure to give you a link to not only Einstein AI, but also to Shane's GitHub repo so you can grab his code at the end. Also, make sure you check out all the great Einstein content on Trailhead. There's a great Einstein Vision trail that we encourage you to complete. We got a bunch of new content coming out over the next few months here as we lead up to Dreamforce as well. We will also be sending out a survey just to see how we did on this webinar. It's really important for us to get that data just so we know we're giving you guys the kind of content and the format you want in these webinars. So please, when you get the email, please fill out that survey. We'd really appreciate it. And with that, as promised, we are on to our Q&A. We have a ton of questions, you guys. So I'm going to go ahead and start kind of firing them off. If you want to pick them up and answer them as you see fit, that would be great. One of the first questions, which is close to my heart, is there going to be a Trailhead module for Einstein Intent?
Yes, we're actually currently developing an Einstein Language module. It'll be hopefully available by Dreamforce, and we will make an announcement when it goes live.
Awesome. Second question, is what we saw in today's demo available for general use?
Great question. So as we link to Einstein.ai, there is a sign-up link there, and that makes you essentially get the entire platform access. That's Einstein Vision and Einstein Language. Anyone can access the site, and because we are in beta, it's available to all with an unlimited usage. Einstein Vision is currently GA, so that one does have a free tier where you can use up to 1,000 predictions per month, but you are able to, any of our services across our platform, train as many models as you want, update your data sets as much as you want, really do a ton of testing and a ton of sandboxing to get your application as close to production ready as possible. And then from there, if you need to go above 1,000 predictions per month, there is a paid tier for Einstein Vision. And eventually when Einstein Language goes into GA, there will be a paid tier as well.
Awesome.
Free prototyping for developers.
Free prototyping.
Yes.
As much as you'd like.
So popular topics. There was a question about pricing. Can you talk to us a little bit about how pricing is going to work?
Yeah. So as I mentioned, that we don't really want to monetize this service for anything that's really in development. So we really think about your ability to iterate on these models is one of the most important things. So once you sign up for our service and you review our documentation, you can start building models right away. And we really don't try to monetize for any other API call besides the predict API call. And this predict API call is actually labeled predict for Einstein Vision, but for intent and sentiment, it's labeled intent and sentiment. And that gives you the ability to make as many predictions as you need. If you go over that 1,000 predictions, Einstein Vision is priced at $4,000 per month for 1 million API prediction calls. We can't really talk in forward-facing statements, but I would say that we're looking to keep this platform very uniform across all of our services and really make it about getting access to the services for production algorithms. So we'll make more announcements later this year once we do get closer to GA. But for the rest of this year, you should be in pretty good shape to leverage the service without any restrictions.
Awesome. And one more related question to just the pricing and signing up for a developer account. There's a question about if it's available in DE orgs, and if so, how would you enable that?
Yeah, it's a great question. So yeah, you can sign up through 2 methods for our service. And if you go to Einstein.ai and click on the sign up link in the top right-hand corner, you'll have 2 links to either go to Heroku sign up if you're a Heroku developer, or Force.com. And if you're a Force.com developer, we allow you to sign up through any of our orgs. So it could be a DE org or it could be an admin org.
Awesome, thanks. Shane, we got a question for you about the data you use to train the model. Does that data ever leave Salesforce for training, or is the data used in place? The concern that this asker had is that the data contains PII or other sensitive data. They obviously don't want that floating to areas where they're not familiar with.
Yeah, that's one of the big things about creating these files in terms of the CSV files or the vision like folders of image examples. Was how do we take those, especially if that data exists in Salesforce, and be able to share them with this external service in the Einstein AI without making that link publicly accessible for long periods of time. And so if you go through the code repository, I didn't highlight this because it's sort of a small feature, but one of the things it does is it creates what's called a content distribution link. If you search in the docs, you'll see what that is for Salesforce, but it's almost like how you would share a file publicly. And then you can set the timer on that. And so it gets this really long cryptic URL. And then you can say, this thing's going to expire after 1 minute. And basically, it needs to be there available for at least enough time for that API call to pick up the file and store it. And then the other thing you can do with that I did not include in the repo, but is probably the production way to do this, would be to write a trigger on what's called a content distribution view, which is the event that happens when someone pulls that file down. And in this case, it would be the Einstein service pulling that file down and ingesting it. And at that point, you can actually delete the file sharing that's there. So it's like a one-time use only public file sharing. I think that's the most secure way I was able to come up with dealing with this. You want to add something to some of those security questions that you get with the service?
Yeah, really, you can look at this as a Salesforce service, but it does need to talk to the Salesforce core applications. So we have all the same security measures in place on the Einstein.ai platform, but we are leveraging separate compute infrastructure. So you are going to be communicating with the Einstein.ai platform. All your predictions don't get saved on the duplicated, but the training data does. So you can do those feedback loops and you can retrain the models. We always do need to retain a copy of that data. So I do recommend, for PII type data, it is worth sometimes scrubbing that because breaches happen, and it's always smart to always, not want to get PII data out the public. But this is in a very secure environment that we hold for your customer data.
Yeah. And for language specifically, these are unstructured text fields, are the only fields that you can really use from the Salesforce schema. And so if you've got for example, long text fields where customers are putting in social security numbers, or those are the types of things that don't really add much to the training. Like someone's social security number is not going to make the model more accurate, right? Those things you would definitely want to strip out of your files before you share them.
Great. I've got another question here about the demo. It's a simple one, I think. The question was, are we the examples we saw in the demo, is that the same beta version that you signed up for on Einstein.ai?
Yes. What you saw on Einstein.ai was the raw API calls. And so that's exactly what I'm using for all the Apex classes. So the only thing I've done is tried to make it easier for people to get started quickly, rather than having to build their own Apex wrappers for those APIs and their own security authentication process for those APIs and the Lightning component so that you can have them on the pages and the process builder interfaces. Everything I have in my repo is just wrappers for Michael's APIs.
Great. Another popular question we got a few times was, is the Einstein Sentiment API only focused on English, or does it have support for other languages? And if so, either what are those languages, or do we have a timeline on when additional languages might be added?
That's a great question. So all of our language algorithms are built in a way, and deep learning kind of enables this, so it can be applicable across any new language that we add to our service. So we don't have to. So right now we're really focusing on how to make these the strongest algorithms possible for CRM type data. In the future, we are going to expand beyond the English language, but at this current time, we are only supporting English for the remainder of the beta. And then once we go GA, we have a series of languages that we will add probably within the first 6 months of the next calendar year.
Great. Some operational questions, I think, just on the platform in general. Do we need to train a standard model when using these APIs?
So, I mean, it depends on which API you're using. The sentiment model is out of the box ready. So you can actually retrain the sentiment model over time. I don't know if I mentioned that, but you can add feedback into it and make it a little bit more specific to your business or the application you're working with. But the intent model is completely customizable. So you really define all of the intents and all the supporting data to actually train that intent model.
Excellent. And follow up to that, what are the processes involved in creating and training those models?
So we try to simplify that as much as possible. If you gather a training data set, and our documentation outlines this pretty well, but you're essentially giving us examples, hopefully in the hundreds, and then the corresponding corresponding labels or classes associated with those examples. So that way, when we see a new example, once you've trained the model, we can output that label. And when you, I think he's going to show it right now on the documentation.
Yeah, there's actually a lot to some of the training stuff. So one of the things that we talked about is there is this public training model. And so when you call training, you can actually pass in some parameters. And one of those is with a global data set. So if you liked this publicly built sentiment model that we're using, but you also have a bunch of your own data that's more about your customers and their sentiment and everything, we can merge those two, right?
Yes.
It's like additive to the existing model.
Mm-hmm.
And so there's a parameter here for that where you can pass in a standard model and your own stuff, right? There's some other training parameters that you can do as well, right?
Yeah, and really this depends on, we always like to say use our baseline architecture to get to that, to really understanding how your model performs. And there's small tweaks you can do. So the train split ratio here, this allows you to decide how much we use for that test data set. So you may say, you know what, I don't really care about the test data set. I got my own test data that I'm going to try this model on that's more production-like. In that case, you would obviously want to keep that split ratio to 100-0. There's also the ability to push that the other way. If you're saying, you know what, I've got a ton of training data and I really, really want to understand the performance, you may say 50% of your training data is actually going to be used for test data. The feedback, obviously, if you have no feedback data, marking this as true won't add any more data. But if you have been sending feedback data to this model, we can train with feedback. And then there's, as you get more and more advanced on this, we have things around specifying the number of epochs. This is how many revolutions through the neural network the actual model trains on, as well as things you can turn on for early stopping. So if you've set a number of epochs too high, and we start to see that the model is getting overfitted or not improving over time through each epoch, we can actually stop the model. So a lot of that is turned on by default based on what we see the most common use cases from our customers, but we do give you the ability to get pretty granular in how you train these models.
Awesome. Follow-up question to that, is there a configuration GUI or graphical interface for configuring these models?
Yeah, so this is all delivered through APIs. Shane's built some components here that allow you to kind of leverage Lightning components, but the out-of-the-box Einstein.ai service is an API-driven service.
Awesome. Let's see here. Tons and tons of great questions, you guys. I'm just kind of trying to sort through all the good ones here and make sure we ask the great questions that are coming through here.
I do want to specify one thing. If you are interested in downloading a third-party application to leverage these APIs, Postman is a third-party essentially GUI over the top of command line that does allow you to have a little bit easier way to replicate API calls over and over again, especially if you're just doing some early testing. That's Postman, Postman.
Awesome. Here's a great question about data augmentation. So the question is, are there any built-in data augmentation tools to offset the disadvantages of having a small data set?
It's a great question. Something we're always thinking about. We haven't seen it come up as much in Einstein Language as we did with Einstein Vision. So we have built some pre-processing tools for Einstein Vision specifically. And if you're interested in those, please post to our support page or customer success page, which we link to as part of the top of our documentation. For Einstein Language, it's very difficult, right? We don't want to actually confuse the model by essentially training it on examples that might not be like your production data. So we do recommend you get as close to your production data as possible when training these models. But as you have needs where you would think data augmentation would help you, we'd love to hear about it and think about ways we can roadmap towards it.
Awesome. seeing lots and lots of questions about the code, about how the demo is presented. Just as a reminder, yes, this source code will be made available to you. Shane was very kind to create some great example code that he demoed. We will be sending out an email with a link to that information. There's also a link to the GitHub repo in the chat, and if we're lucky, maybe Mike, we can convince Michael to put a link to Shane's demo code on Einstein.ai. Awesome.
I have a question.
Yes.
So we talked about the low end, which was I didn't have nearly enough examples in my easy demo. Is there too much? Is there a upper end?
It's a great question. If you're dealing with let's say you're leveraging historical cases within your company, and your company's been around for 100 years, and you're dealing with millions and millions of cases, you need to, while we can handle large data sets, we do have data set restrictions as far as how much you can upload. So it's a gigabyte at a time for any URL, and so you can make multiple uploads to our site. But more thinking about the problem set in general, things change over time, right? There might be, if you're trying to predict product type or departments change names, product types go end of life, you might want to review your data and really see, do I really need to use all 10 million of these cases? And I'd always suggest starting small. Maybe start with the first couple thousand cases that are most recent, which probably reflects the most recent products or most pertinent departments handling cases. And then start adding in historical examples as you see fit to really get that model to perform level. If you add in 1 million examples all at once and you have bad signal, then you're starting to strip data away rather than adding incrementally, which gives you a little bit more advantage of seeing how the model is improving over time.
Great. Here's an interesting one. This is kind of related to our questions about data security. And I'm going to try to make sure I get. I'm going to read the question verbatim and try to put my spin on it and see if I interpret it correctly. But the question is the data center for the Einstein service the same as the instance of the user? So I'm assuming that they're asking, is the data living in the same org that the user logged into? Now, I think we covered that earlier.
Yeah, we do have a separate org structure than the Salesforce core org. So you actually, when you sign up for Einstein.ai, you will create an org ID that is different than the org ID of your core application. And so tying those two together, that's what a lot of these Apex wrappers help you do.
Awesome. Question about a use case. Could you use the language intent service in a live chat support situation?
Yeah, I mean, it's a great way. So you might have 100 KB articles that are the most likely KB articles to pick, and those can be your intents. Your intents definitely can vary. It's more like categories than intents. So you could leverage, making a service rep more efficient because we're a real-time API with sub-second returns on our predictions. As a case comes in or someone's chatting with a representative, you could try to predict the most likely KB article to help them, or maybe even a macro that you've created to answer that question. A lot of interesting ways to apply this. We're starting to see new ones all the time, so I definitely recommend experimenting with the service and seeing what it can do.
And you can do that for your cases pretty easily because you should have attached articles. That would be a simple data query, and then your labels would be the article IDs or names or something like that. Yeah,
really look at your data that's in Salesforce, and you might have an unstructured field. You can combine necessarily multiple fields like subject and description as part of a case as a single input into our model, and then leverage one of the what maybe somebody's hand labeling as an output, but you have a lot of historical data to represent that.
And I just want to add one thing. Without getting too much into trouble with the Service Cloud roadmap people, you will want to come to Dreamforce or watch the video and take a really good look at the Service Cloud roadmap, because some of the things that I originally wanted to do with this were things that they were in the process of working on. And so that might be something that you totally could build with this and may have good reasons to, but you also might not want to.
Really glad to include that safe harbor slide, Shane.
That's right. All right, Service Cloud, you know where to find me.
Here's a question that's near and dear to my heart coming from Team Trailhead. Is there any chance I can be trained on Einstein by Salesforce? For example, a Salesforce University course, or perhaps a Trailhead module?
Yeah, so I kind of called that earlier. There is an Einstein Vision Trailhead currently available. And really, when I talk about the Einstein platform, leveraging the Einstein Trailheads, specifically the Einstein Vision and the Einstein Language trailheads, really give you a good overrun of the entire platform. Now we're talking about language, so the input is text versus images, but a lot of the same concepts that apply to Einstein Vision apply to Einstein Language. So taking both the Einstein Vision course now and a couple weeks the Einstein Language course will be mutually beneficial and really allow you to leverage the entire platform service.
I apologize if you guys already covered this one. I might have missed it. The question is around data set sizes. What's a good size for test data? Sorry, the question is, what size of test data should be considered as good to train a model?
There's a lot of factors that go into this. So one, how many classes you have. If you have 2 classes, a binary classifier, two labels as per our documentation, but labels in classes I've been using kind of interchangeably, so I apologize for that. If you have 2 labels, you might not need nearly as much data as if you have 100 labels. And so you really need to look at your use case. If you have 2 labels that are very, very different than each other, then the signal is going to be able to be picked up a lot quicker than if you have 2, if you're asking how to change password or how to reset password, those might be very, very similar service case questions. But returning a product and resetting a password are very different. So we'll be able to adapt to that signal a lot quicker. So I do suggest 100 to 200 as being a great starting point for any intent you're making. And
for each label.
For each label, and then seeing how that actually looks. Now, if you're having trouble getting there, there's always ways to think about new ways to ask a question, new ways to reformat that data to try to supplement it as quickly as possible. But any data scientist will tell you half their time is working with data, reformatting data, cleaning data, adding new data, thinking about ways to extract new signal from that data. So it comes with any artificial intelligence application. Data is really at the heart of it.
Is there a possibility for someone who may have that problem? I'm not sure I have enough data, but I would like to build this, and then maybe as users use it and make corrections to it, they get smarter with the feedback loop. Is that a viable process? How do you think that would work in real life?
Yeah, it all depends who your end user is and how much they're willing to tolerate errors.
Yeah.
If you're dealing with a very close-knit group where you're able to communicate with them well and let them know that this application might not be perfect, but the only way we're going to make it stronger over time is adding in this feedback loop and allowing our users to be high quality, essentially data aggregators and adding to your data sets. Now, if you have an application where that threshold's very low, or you don't trust your end users to really give you high quality data feedback, it might not be the best way to implement your application.
There's another approach to that, which is running this stuff in secret behind the scenes where the users don't know it.
Yeah.
So when I created the original one for cases, I actually had a custom field called predicted classification, and my feedback loop looked at whether predicted classification matched what the users are actually putting. So there's a process of maybe building up that data and trying out the model without releasing it to your users, just by keeping that field hidden and then tracking how often. You could do a simple Salesforce report on whether those 2 fields match how much of the time, right? And then if you start feeling good about it and you realize, oh, we're mostly good, maybe then you can roll it out to your users, like a pilot group. And because these are just custom fields in Salesforce, you can use all the traditional blue-green testing and phase rollouts and pilot groups with a permission set on those special fields. It's Salesforce. You get to do a lot of cool things.
Yeah,
that's clever. Similar vein, there's a question about the best practices for cleaning external data needed for training models. Have you got any input on how people might approach cleaning external data for their training models or for training their models?
There's a lot of applications out there that can help you out. We really try to simplify the way to input data to can be as simple as just a CSV file to upload to our folder. So as you're thinking through, if you're trying to clean up the characters or dealing with PII, I'd recommend looking up, searching through, and seeing what applications are available there to help you.
Great. Another security PII kind of question. Does the org for the Einstein services and Salesforce instances, I'm trying to rephrase this question in a way that it's a little bit more clear. In summary, there's a question about if the data resides within the same data center. So if I have my standard org and my Einstein org is at the same data center. So I'm assuming this is a question about geographical where the data lives at rest geographically.
Yeah, right now we currently run in a US-based data center that is outside of the core data center. So it'll likely be guaranteed to be in a different data center.
Great. That is about it. We are running up on time. First of all, thanks everyone who's attended for all the excellent questions. Thank you, Katie, Michael, and Shane for taking time with us today. I think this is a really awesome webinar. We really appreciate you guys taking the time to share all this great stuff with us. Thank you guys.
From the Dreamforce, we'll give you more.
Yeah.
Thank you.